We're going to break this up into two parts. Before we do the extreme value theorem, you need to know what critical values are. So hopefully by the end of this, I don't know if you can hear my daughter walking around. She's got cute little shoes on. Anyways, by the end of this, you should be able to find critical values and critical points of functions. The only difference there, a critical value is just the x value, or x coordinate, and the critical point would be like the x and the y. Okay, you should also, after the second part, be able to use the extreme value theorem to find extreme values of functions and where they occur, which is a fancy way of saying finding a maximum and a minimum. So, to be successful in AP Calculus, you need to know the difference between an extreme value and where that value occurs. I know, at least at our school, the common thing for the pre-calculus teachers to say is just write the ordered pair and you can never be wrong. Turns out you can. So, I'm going to keep saying the same definition over and over. A critical value is one that makes a derivative equal to 0 or undefined. And usually when we say critical value, we mean setting the first derivative equal to 0 or undefined. But we'll also do that for maybe a second and third derivative later. So a critical value is one that makes a derivative equal to 0 or undefined. One more time. A critical value is one that makes a derivative equal to 0 or undefined. Okay. Now, the reason those are important is critical values are the only places where maximums and minimums can occur, unless we're talking about an endpoint. So here is x squared, where it's critical values. Well, a critical value is where a derivative is equal to 0 or undefined. By now we know the horizontal tangent, right here, that is where the derivative is equal to 0, so that's the only critical value for x squared. And notice, minimum. X to the 2/3 power. X to the 2/3 power has a minimum at x equals 0, and you should recognize that as a cusp, a place where a derivative is undefined. Remember, critical values are where a derivative is equal to 0 or undefined. Okay. Where is this derivative equal to 0, or the derivative of the absolute value of sine of x? If you need it, what is going on here? G of x is the absolute value of sine of x. Desmos doesn't give me pretty on absolute value. And, well, this derivative is equal to 0 at these horizontal tangents. There are infinitely many of them. 1 at pi halves, 3 pi halves. And the derivative is undefined at these corners at 0, pi, 2 pi, and so on down the line. What's a critical value? Say it with me. Critical value is where a derivative is equal to 0 or undefined. All right, x cubed minus 9x. Are there any critical values here? A critical value is where a derivative is equal to 0 or undefined. X cubed minus 9x has two critical values. I don't know why that seems like a weird number. Oh, because sorry, I was trying to factor, and turns out we're looking for derivative. Anyways, so just so we're clear, when you're asked, hey, what is the maximum, what is the minimum, that is the y value. The maximum is 5. The minimum is 0. Like the maximum number of dollars in your bank account, right? That's asking how much, the output. And that maximum or minimum occurs at the x value. So you might be asked, hey, where does f of x have a maximum? You're expected to just give the x or the input. Okay. So for example, right here, hopefully you recognize this as y equals cosine of x. And y equals cosine of x has a maximum of 1. You could even say of y equals 1, just to make sure, which occurs at x equals 1. At x equals 0. Obviously, it has multiple maximums, but I just cut off the graph here. So here, notice, even though I've given the ordered pair 0, 1, I've added in the additional information about, hey, the maximum, the biggest y value is 1, and the place that that happens is at x equals 0. So I think it's always good to do both of those. And in my examples, I'll usually do both, just so when one or the other comes up, you're okay. Because if this was your answer, hey, what is the maximum? Well, that's pretty obvious based on the structure. Hey, the maximum is 1. Okay. Anyways. So there's some vocabulary things you need to know. A relative maximum, I don't think you're going to get confused on maximum and minimum. I know you know a maximum is the large one and the minimum is the small one. Okay, but what is a relative maximum? A relative maximum is some place, or is the y value, like right here f of b, right? F of b counts as a maximum. It's the y value where the y values near it are lower. Does this graph have another relative maximum? It sure does. That relative maximum is at d, and I guess is f of d, right? Because if you think about all the y values that are near f of d, all of the points on the graph are lower than the point at d, something like that. So what the heck is a local maximum? A local maximum is just another way of saying relative maximum. Those mean identical things. So I guess we could say, what about minimums? Well, this graph f of x has a local minimum at x equals a and a local minimum at x equals c. Likewise, there are two ways you're going to be asked to find the largest of all y values. That is either global maximum or absolute maximum, and those mean the same thing. Now, there is a nice trick. College Board, if you're asked for a global maximum and absolute maximum, you're always going to be given a continuous function on a closed interval because you're expected to use the extreme value theorem. But we'll worry about that in part 2. So we already said that, notice it's the same graph, f has a local maximum at b and a local maximum at d. And so when we're talking about global maximum or absolute maximum, that's just, well, which of those candidates, which of all the local maximums are the highest? And of course, the absolute maximum, the global maximum of f on the interval a to d is f of b, or basically, this highest high point is the absolute maximum, is the global maximum. Okay. So we'll finish off with 2 examples about what it's going to look like to find critical values. Just we're going to break that off. Relatively easy topic. So what is a critical value? It's been a minute. Do you guys still say it's been a minute? It's been a minute since we've said that. A critical value is where a derivative is equal to 0 or undefined. So we find the derivative of x squared minus 3x plus 2, which of course is 2x minus 3. So from there, we do both halves. And x squared minus 3x plus 2 is a polynomial, so it's never going to have a derivative that's undefined. But turns out, like a lot of things, that's going to be the normal case. And if you don't always think about, hey, is this derivative undefined, then when that comes up, you're going to forget about it. So I will tend to always give both. I'm going to, in my work, have, okay, I'm going to set this derivative equal to 0. I'm going to look for where this derivative is undefined. And if I know one of those is not the case, I'll just write it out. Anyways, so 0 equals 2x minus 3. Add 3, divide by 2. X is 3 halves. That's the only critical value we get here out of y prime. Okay, what about x to the 2/3 power? How do we find critical values? Critical values are ones that make a derivative equal to 0 or undefined. So we're going to do 2/3 x to the negative 1/3. I'm always encouraging my students to rearrange. Notice it's actually a lot easier to figure out where this derivative is equal to 0 and where this derivative is undefined. So where is y prime undefined? Well, when the denominator is 0, and in this form it's pretty obvious that if we put a 0 right here for x, well, the denominator would be 0, y prime, this function, would be undefined. So we can just make that statement instead of doing the algebra. Likewise, if we wanted to set this thing equal to 0, let's go back one. If we wanted to set this equal to 0, well, the first thing we would do would be multiply both sides by 3 times the cube root of x. We get 2 equals 0. Of course, that's not true. Or another way to say that, to make a function equal to 0, set the numerator equal to 0. Of course, can't. 2 can't be equal to 0. Anyways, so we get the only critical value here is x equals 0. All right, time for some practice.